Good afternoon. Today we are with third lecture on design, and totally we will say revision lecture we have 14. One design we have seen single angle, another we have seen double angle. Now we are with channel, that is built up column. So design a laced. So this is again important, laced built up column to carry a factorial load of 1100 kilonewton. The length of column is 12 meter. The column is restrained in position. Restrained in position means we have translation. And at both ends, but restrained in rotation, that is direction or rotation at one end. Channels are connected back to back. So step one, we know we have given data. So step one, given data. So we have given P, that is factorial load 1100 kilonewton. So 1100 into 10 raised to 3 Newton. Then L is given 12,000 millimeters. Now condition we have restrained in position at both end, but restrained in rotation at one end. So we have restrained over here, and here is not restrained. So we have like this. Here we have like this. Means we can say one end, if we will see, if I will draw larger scale, then we have slope 0 for some portion, and then here we have slope over there because rotation is allowed. And here rotation is not allowed. And this length in IS 800 table 11 is given as 0.8 into L. And so we have L effective is equal to 0.8 into 12,000. And that will be is equal to 9600 millimeters. So this is given data. Then we have step 2, selection of section. Selection of section. Now length is large, and therefore we will assume FCD. We can assume from 120 to 150, 160. So as length is 10 meter, so we are going to assume it as FCD. Effective length I am saying near about 10 meter. So FCD we will assume 120 MPa. If length is less, then we can increase this value. Therefore, area required. Area required equal to P upon FCD. Now P we have 1100 into 10 raised to 3 divided by 120. And we will get this value, that is 1100 into 120. Sorry, 1100 into 10 raised to 3. 1100 to the power 3 divided by 120. 9166.67 mm square. Now area required for single channel. Area required for single channel. That is equal to 9166.67 divided by 2. And then we have this value 4583.33 mm square. So we will select ISMC 300. ISMC 300 at, so just go to IS 808. So we have 351.2 Newton per meter. You can have IS 800 also. If you will go to the IS 800 and we have Annex H, and there we can have this value ISMC 300, and that ISMC 300 we have. In this, we have given this as 358 Newton per meter. So small difference you will come across. So here if we will see, we have 358. So in IS 358 Newton per meter. But ISMC 300. So this may have difference if we will go to different book. Then we have step 3. Properties of section. Properties of section. Then ISMC 300, we have area 4564. 4564. Now you will say that required is 4583, and then we are providing 4564 lesser. So it is close because we do not know if FCD is correct or not. So that is very less, very negligible difference is there between the two, and therefore we can have this 4564 mm square. Otherwise it will be on higher side, and then that will not be economical. And then we require value of RZZ, and we have 118.1 millimeters. RZZ 118.1 millimeters. Now we need not require to find out other values. That is RYY. Now try to understand this, why we are saying RZZ as minimum. Because this will be back to back. And this as we are going to provide in such a way that my value of IYY should be greater than IZZ. And if I am going to provide in this fashion, so automatically my RYY will be greater than RZZ. And therefore we have RZZ as R minimum. Now we have step 4. Step 4. Design compressive stress. Design compressive stress. And then we have, that is L upon R minimum. Now L we have 9600. We can have here 9600. And R minimum, we have RZZ 118.1. So we have 118.1. And if we will calculate this value, that is 9600 upon 118.1, it comes 81.29. Now we have buckling class. You can have step, another step, or you can be in this step, buckling class C for built up members. Class C for built up members. And therefore use table 9C. Table 9C. And then we have step 5. Design compressive strength. Design compressive strength. Now for last column, we have L upon R minimum increased by 5%. That is given in IS. And therefore, L upon R minimum for last column equal to 1.05 into 81.29. And therefore, we will get 81.29 into 1.05, 85.35. Now we have KL upon R80. and 90. And value of FCD we will have. We have to go to table 9C. So 9C page number 42. For 80, we have this value, that is 136. And for 90, 121. So 136 and 121. For 80, 136. For 90, 121. And therefore, we will get FCD equal to 121 plus 136 minus 121 divided by 10 multiply by base we have taken 90. So 90 minus 85.35. And from this we will get value of FCD, that is 136 minus 121 divided by 10 multiply by 90 minus 85.35 plus 121, 127.98. See, we have taken 120, so it's too good for your assumption. So PD is equal to AE into FCD. Now AE we have 2 into area we have seen 4564 multiply by 127.98. And from this we will get value of PD 2 into 4564 into 127.98, and it comes 1168. So it is 1168.2 into 10 raised to 3 Newton equal to 1168.2 kilonewton, greater than 1100 kilonewton, therefore safe. And then we have last step, step 6, spacing between channels. Step 6, spacing between channels. Between channels. So we have I ZZ less than or equal to YY. That is of whole section. So we can have 2 into IZZ of individual equal to, now try to understand this. IZZ of individual section and IZZ of whole section are along the same line. So we are being like this. So we have ZZ for both along the same line. So we have to directly multiply it by 2. But now YY we have along this individual and whole section we have been along the center. And so we have this distance as CYY. And this distance will be S by 2. So we have total, this will be S spacing of channels. And therefore 2 into IZZ equal to 2 in bracket IYY individual plus A into H square. So this 2 gets cancelled. We have value of IZZ and value of IZZ we have 6362.6 6362.6 into 10 raised to 4 is equal to IYY we have 310.8 into 10 raised to 4 plus area we know 4564 into CYY we have 23.6 plus S by 2 whole square. Already I mentioned we have, this will be my H. H is the distance between the individual axis to the whole axis. This will be CYY plus S by 2. And from this we will get 23.6 plus S by 2, which is equal to root of 6362.6 into 10 raised to 4 minus 310.8 into 10 raised to 4 divided by 4564. And from this, we will get this value of 23.6 plus S by 2, that is 6362.6 minus 310.8 divided by 4564 root of this 115.15. 115.15. And then we have S by 2 is equal to 115.15 minus 23.6 minus 23.6. So 115.15, 23.6, 91.55 millimeters. And therefore, S equal to 183.1 millimeters. Now from this we will get IYY equal to IZZ. But we have to provide IYY greater than IZZ so that section will be economical. And therefore S should be greater than 183.1 millimeter. And therefore provide spacing of channel 190 millimeter. Provide spacing between channel equal to 190 millimeters. So likewise, we have to solve the problem of design, and that is built up column when channels are back to back. So now we will stop here only. Remaining part we will see in the next lecture. So thank you.